And welcome back to another LeetCode video. Today we're looking at 424, longest repeating character replacement. This is a sliding window problem, and I'm just going to show you how to solve this one. So you're given a string s and an integer k, and you can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. And then we were supposed to return the length of the longest substring containing the same letter you could get after performing the above operations. So here's an example. Here we have the string ABAB, and we're allowed to replace two of any of the characters in the string with any other. And you can see the output is 4. And when we replace the two A's with B's, that becomes 4 repeating B's, and vice versa. If we replace the two B's with A's, we get the same result. Here's another string, but now we're only allowed to replace one character with another. So the maximum length, well, if we start iterating over the string, we run into AAB. That means we're going to replace the B with an A, so that we length 3. Then we consume the next A, so that becomes length 4, and then we run into B. However, we've already exhausted our number of replacement that we're allowed to make. So in the end, the output is also 4 here in this case, matching the prefix and switching the one B into an A. So how are we going to approach this? Well, we know that the string has at least one character, but we might not be allowed to make any modifications. And so the challenge with this problem is to define when to contract the window, and because the window should always contain the longest repeating, or the longest substring that contains only repeating characters after replacement. So let's just write the surrounding code that we need for this. So we know that we need to return as a result value, and we'll initialize that with 0. And we also know that we're going to need a window of some sorts to keep track of the character count that we have in it. So let's define that as well. And we're going to use the hash map for that. And then we will have, well, we have a left pointer and a right pointer in our window. So we'll have a left one. Well, we have a left pointer and a right pointer for our window. The left one points to the first character that is in the window, and the right one points to the last one. So what we're going to do is we're just going to iterate over all of the characters with the right pointer. Enumerate string. And well, every time we run into a character, we have to increase its count in our window, right? Plus equals 1. Right. Now, we will have some sort of condition here while something, we need to contract our window, and we'll flesh that out in a moment. And what we'll do here is we grab the character on the right, on the left, and that is s at the left pointer, and we're going to decrement the frequency count for that character in our window by 1. And I think it's also good practice to clean that value up. So if it goes to 0, we might as well evict it from our hash map, right? So if that value is equal to 0, we're just going to delete it. Cool. And of course, we need to increase the left pointer as well. Now, following the pattern of how to do sliding windows, which is currently what I'm writing out, we're going to have, well, our result is going to be the previous maximum length that we were able to get for a substring that contains only repeating characters. So that'll be max result. And of course, the size of the current sliding window. And that is always right minus left plus 1, because if right and left are the same, there's still one character in there. So to fix this off by 1 error by the subtraction, we have to add 1 here as well. And yeah, so this is kind of the basic scaffolding for the sliding window approaches. Now, how do we figure out when to contract the window? Well, the one insight is that we have to, well, when do we have to contract the window? Well, that is when we have, I guess, well, one thing to note, and this LeetCode problem doesn't really express it well, you know, we can choose any character. Doesn't mean that we have to pick one type of character. So it doesn't mean we can only pick A's. We can pick any character. We can pick A, B, and C. If K is 2, we can pick A and B to replace it with C each, right? So that is not stated clearly in this problem, but this is what we're allowed to do. So what we really only care about is how many characters do I have in my sliding window that are not the most frequent character, because we're going to keep the most frequent character in our window from the original string and then just replace the other ones with K, right? Because it doesn't make sense if we have a window like this where we have more B's than A's. It doesn't make sense to replace the B's. So we want to replace all of the characters that have a count that is smaller than the most frequent one. So one thing that we need to keep track of, what is actually the most frequent character in our current window? We're going to need another variable here for that. Well, we could call this window max frequency, and we initialize that with 0. So when we increase the count on a window, we also have to update our max frequency, right? So what we will do is we'll say max, max frequency equals the max of max frequency, and of course the window, the frequency of the character that we just increased. So we will do that, and we will use this information now to compute how many characters do we have in the window that are not the most frequent one, right? And those are the ones that we want to replace. So we're going to calculate the size of our window. That gives us how many characters are in the window actually itself. And well, we have to subtract the character count for the character that has the highest frequency, right? So this gives us the total number of characters that are not the highest frequency that we should replace with K. So if that number is higher than K, we need to start removing characters until we don't have that anymore. Right. And another thing to note is you see that the max frequency, we're never going to decrement it because we don't need to. If we run through the array, you know, once we have a max frequency, there's no way we're going to find another longer substring where we can actually get where we can find where we can replace more than K characters, such that we get an even longer substring with repeating characters. So once we find a max frequency character in our window, the only way to beat that is to find one where the max window is even larger. Sorry, the max frequency is even larger for the character that has the most repetitions in our window. So that's why we never have to adjust this as we pop elements out of our window on the left side. And yeah, that's pretty much it. So that's the magic trick, how to calculate how many characters how many characters do you have to replace, and then just make sure that that count is not larger than K. So if I run this now, it should pass all of the tests. Right, and let's submit this. Nice. So yeah, so that concludes that problem. Oh, we forgot one more thing. The complexity analysis. Obviously, we're just iterating one time over the entire array, so that's going to be O of n time. And so each pointer goes over the entire array. So it's still O of n time. And how much space? Well, worst case is O of n space, where the window is the maximum size, where, for example, when all characters in S are the same letter. And yeah, because then We see then right minus left would be n. Oh yeah, so if all are the same letter and the max frequency is then that single character, and it's never going to be larger than k, regardless of what value k is. So this is O of n space and O of n time. And yeah, I hope you give this one a try as well.